Now we're going to use the fundamental theorem of algebra for this. This problem, the directions ask us to write a polynomial function with real coefficients. That's important. You kind of just like brush over that, but that's important. It wants real coefficients satisfying the given conditions. And the conditions are this. N equals 3. That's our degree. So it's going to have a degree of 3. The 1 and the 5i, those are zeros. Let's label that. So these are the zeros for our function. And then right here, this is our function. We don't know what it is, but if we plug in -1, we're going to get negative 104 as our result. So how do we create this? Well, the fundamental theorem of algebra says that there exists a factor, x minus c sub 1, and there's other ones too, such that you can factor any polynomial. Any polynomial you can factor and into factors with x minus c sub 1. So what that means is this. I mean, you guys are going, what? What the heck? Well, guys, if you have a 0 that equals 1, what's one of the factors? Yeah, it'll be x minus 1. That's not, like, revolutionary. X minus 1. Because you think, in order to get 1, we would have to set this equal to 0. You know, we would be using the 0 property, and we would get 1. What would the other one be? X minus 5i. That one makes sense too, because if I add 5 to both sides, if I set it equal to 0, I would get 5i. But the problem is the directions say find a polynomial function with real coefficients. Now, is this number real? No, he's fake. He's imaginary, just like your friends.
Oh.
So in order to get rid of an imaginary number, we have to multiply that imaginary number by another imaginary number. So we get an I squared. Once we get an I squared, the imaginary number is gone. And so if ever you have a complex number as one of the zeros, you also have to write its, I guess you can call it the conjugate, as one of the factors. So if x minus 5i is one of the factors, then x plus 5i has to be the other factor. And so now to find our polynomial, we just have to multiply everything out. Okay, now I would multiply these ones first just because they would make a difference of squares because they're conjugates of each other. You know that they're conjugates of each other if they have the same exact terms, except one of the terms is the opposite. Okay, so when I multiply these out, I'm going to get x squared minus 25i squared. Now, do you guys remember what I squared is? Well, do you guys remember what I is? Square root of negative 1. So if I have the I squared, that would be the square root of negative 1 squared. Right? And then the square and the square root would cancel each other out. You'd be left with negative 1. So really this is saying x squared minus 25 times negative 1, which would be x squared plus 25. You guys with me still? Okay, cool. Now I'm bringing down the x minus 1, and I'm going to finish the job here. Let's continue distributing. We have x times x squared, which is x to the third. And then we have x times 25 would be 25x minus x squared minus 25. When I put this in descending order, it would be x to the third minus x squared plus 25x minus 25. So here's our polynomial function. But is that correct? Is this function correct? I don't know yet. What I would have to do is I'd have to plug in negative 1 to see if I get negative 104. Huh. So let's try it. Let's plug in negative 1. So we have f of negative 1. When I plug in negative 1 to this would be to the third plus negative 1, whoops, would be minus negative 1 squared plus 25 times negative 1. And then finally we have minus 25. So we simplify this, we get negative 1, and that's going to be a minus 1 plus negative 25 minus 25. And when I add those all up together, what do you get? Negative 54. No, not 54. 52, right? Dang it. It doesn't match that. Can you think of something that we can do? Yes?
Can you just multiply everything by 2?
Yeah, why not? Can you just multiply everything by 2? Does that change the zeros of my polynomial function?
No.
If I multiply everything right here in my polynomial function by 2, will it change the function? Oh, it does. It changes the function, but does it change the zeros? No, it will just stretch the graph out, but the zeros will stay the same. So we can just multiply everything in this guy by a 2, and that would give us a negative 104 instead. Let's take a look at a graph and see what that looks like. Let's see. First, I'm going to do this out. And actually, what the book tells you to do, it says if you have a graphing utility, use that to help you with it. So it'll be 2x to the second plus 50x minus 50. So let's go over to our friend Desmos and check stuff out.